Hey guys, welcome back to another Algebra 2 video. In this video, we're going to talk about how to find the vertex of a parabola or a quadratic using something called the vertex formula. All right? So let's just start out by reminding ourselves what a vertex is. First of all, what is a parabola? Well, parabola is the shape that a quadratic makes, right? So a quadratic is a function that has a square in it, right? And the parabola is this shape. And the vertex is going to be this point down here. So this point down here is the vertex. And it's very important to know what that vertex is for a bunch of reasons. One, it helps us graph it because it's where the starting point is, whether it's down there or up here. Either way, this is the vertex. But it also helps us because it lets us know what the lowest value or the highest value of this function is. So there's a lot of useful information we can glean from knowing the vertex of a quadratic or a parabola. All right, let's remind ourselves how we found vertex last time. So you might be thinking to yourself, we did this last time. In our last video, we talked about how to graph parabolas by factoring, right? So let's say we factored something and it gave us, just a little review here for a second. It gave us something like this, right? Now, let me write a little better. And we learned from that our roots were -5 and -1. And so we went over here and we graphed this, and we remembered that there was a pattern to these dots on this quadratic, right? And we were able to fill in the dots, and then that actually gave us our vertex. So here is the vertex down here. This is our vertex, and the coordinate is -3 and then -4. So in this particular case, for this quadratic, we were able to find the vertex quite easily because we were able to factor it and then graph the roots and then go down here and count because we knew that picture, right? But what if we couldn't do that? What if we have some kind of quadratic that we can't factor easily? Or let's say we have a quadratic that when we factor it gives us, let me use a different color so I'm not too confusing here. What if our quadratic didn't line up with our picture? See how this one is 3 apart? Well, this isn't going to quite line up. It's going to be somewhere in here. It's not going to line up on one of these whole numbers. So in those cases where you can either factor it doesn't line up perfectly with our dot system, or you can't find it, you can't factor it at all, you need some way of finding out what this vertex is. All right? And that's what we're going to do today. We're going to figure that out. All right, so to be very clear, a vertex is a coordinate, right? So if I say, what's the vertex of something, I'm not asking for a number, am I? I'm asking for a point. So let's actually draw one. Let's say I want to find the vertex, and let's say it's over here. Now, you don't know this yet. This is the whole point. We're trying to find it. But suppose that the vertex will be over here, and it could look like that or look like that, either way. But this is our vertex. What is the information I need to define a vertex? Well, the vertex is a point in space. It's not just a number. It's a series of numbers. I need both an x and I need a y. Okay, so to find the vertex, to be very, very clear here, I need both an x and I need a y. All right, so what we're going to do is we're going to use a formula to find the x value first. I'm going to go ahead and outline this as just kind of a broad process, and then we'll go into an example. But we're going to use a formula to find this. So let me actually write that for you. There's a formula, the vertex formula, to find this number. It's not going to find both numbers. It's just going to find the first one. But when you use that formula and you get that number, you have to recognize, wait a minute, even though this is called the vertex formula, this did not give me the vertex. It only gave me half of it. So what you're going to have to do is take that and do something with it to find the y. So if I were to give you an x and you had some function and I asked you to find y, what would you do? Well, to find this y value, you just plug it in. So let's actually go through this. So you're going to use the formula, step 1, use vertex formula. I know I haven't even shown you the vertex formula yet, but I think it's probably a good idea to get our minds wrapped around what we're going to do first before all the numbers start flying everywhere. So use the vertex formula to find x, the x coordinate, Okay, that's only half of it though, right? You have to find both. And then to find y, we're going to plug back in. Plug x into the quadratic, the original function, right? To find y. And then you put them together and you have an x and you have a y. Then and only then will we have our complete vertex. Okay, so let's do one. Let me get rid of this here. All right, so before we show you the function itself or the formula itself, we've got to talk about what the anatomy is of one of these quadratics. So let's say I have a quadratic that looks like, let's say 3x squared plus 12x minus 5. All right. Now, can we factor this? Probably not. I'm not going to try to factor that. But what we want to do is try to find the vertex anyway. What we have to do first is assign some things, some letters to what we see. That way we can talk about all these quadratics in the same way. Here's what I mean. We're going to define the number in front of x squared as a. So whatever number you see in front of x squared, that's what we're going to call a. A is 3. A is not x squared. A is not 3x squared. A is just 3. It's just the number in front. This number we're going to call b. So that's positive 12. And this number over here we're going to call c. Now it's important to note that c is not 5. C is negative 5. So you take the entire value, right? All right, so now that we know what the parts are of a quadratic, now we can actually use a formula to find the vertex. So here it is officially, finally, the vertex formula. The vertex formula. Oh. And remember, it's only going to tell you the x, so we're going to write x equals. And that's because this formula only gives me the x part of the vertex. X equals negative b divided by 2 times a. Very, very simple formula. Okay, let's use this formula to find the vertex of this quadratic. So first you're going to identify what b is. Well, we've already done that. B is what? B is 12. This formula says that x is going to equal negative b. So I write negative, so minus sign, and then 12, because that's b, divided by. Then the formula tells me to use a 2. I will always use 2, because 2 is in the formula. This is hardwired. This is locked in. So I'm always going to use 2 there. And then times a, whatever a is. So in this case, a is 3. All right. So now I'm going to simplify this. Negative 12 divided by, what's 2 times 3? 6. Now I have negative 12 divided by 6. And that's going to give me negative 2. All right, great. So now I have the first coordinate. Now remember, this is not the vertex. This is only giving us half of the vertex. How do we find the rest of it? Well, whenever you're given an x value and you want to find the associated y value for a particular function, all you have to do is plug it in. You plug in x, you get y. So let's plug in negative 2 into this function. So I'm going to go down here. I'm going to write 3. Instead of x, I'm going to write negative 2. 12 times negative 2 minus 5. Okay, let's remind ourselves how to work this out. When you're doing things like this and evaluating functions, make sure that you do exponents first, right? So you're not going to multiply 3 times negative 2. You're going to square it first. So negative 2 times negative 2 is a positive 4. This is 3 times 4. Now I'm going to look at this as a whole and say this is 12 times negative 2, which is negative 24. And then minus 5. It just comes down. All right, so 3 times 4 is 12, minus 24, minus 5. What does that give me? That gives me, well, 12 minus 24 is negative 12, minus 5 is negative 17. All right. Now, again, that's not the vertex either. The vertex is the combination of those. So the vertex, again, is a point. Remember, it looks like this. Here's the vertex. It's a coordinate. I need an x and a y. What is my x coordinate? It is the -2 that we found from our formula. And the y is the number that we got when we plugged that x coordinate in. So that's going to be -17. And that is all there is to finding the vertex of a quadratic. Okay, let's do another one. Let's try this one. Oh, I need a square for it to be quadratic. All right. If you're feeling confident, even if you're not, I would suggest pausing it anyway and giving this a shot, and then come back, and then we'll work through this one together. Okay, here we go. Let's go ahead and label these. Now, you don't have to label them, but I'm going to give you a couple different tools here. So A is 2. Some people like to write them out like this explicitly. B is -8, and C is 3. Now, notice that we didn't actually need C to do this formula, but it's good to be aware of what C is because we are going to use it later in something else. All right, let's do this. Now we have -b, which is -0. Now, what is b? Well, b is -8, and it's not 8, it's -8. You have the whole thing. So if I have -8, that's going to end up just being a +8, right? That's how that works. But I'm going to write it out this way so you can see that this is, in fact, the way it works out. So it's -8 divided by 2 times a. In this case, a is 2. So now this is +8 divided by 4, which gives me +2. Again, I'm not done. I have to do something with this. What do I do with it? I plug this in. So I go down here, 2 times, and then x is 2 squared minus 8 times 2 plus 3. Doing the exponent first, 2 times 2 is 4, times 2 is 8. This is now, when you do this, don't write minus. I wouldn't yet. Just to be careful with the signs. This is -8 times +2, which is a -16. Then I write down -16, then plus 3. Now that's going to be -8 plus 3, which is -5. So my vertex is going to be 2, -5. Very simple. All right, let's do yet another one. I'm going to get really good at this. How about this? That'll work. All right, try this one real quick and then come back and we'll do it together. All right, let's do this. X equals -b over 2a. Well, b is 6, so I have -6 divided by 2 times a. In this case, remember, a is the number in front of x squared. Is there a number in front of x squared? Yes, there is. What is that number? Well, it's 1, because you can always multiply 1 times something, and it doesn't change it, right? So that you can always imagine that there's a 1 being multiplied by anything. So it's just 1. So that's what a is. So 2 times 1. So that's -6 divided by 2, which is -3. Now what we're going to do is take that and plug it back into our original function. So I have -3 squared. Make sure you use parentheses when especially when you have a negative that you're plugging in, so you don't mess things up. Plus 6 times -3 plus 2. Now I have -3 squared, which is 9. 6 times -3 is -18 plus 2. That's 9 minus 18 is -9 plus 2 is -7. So my vertex is, I'm going to make sure I label it, -3, -7. Now what you can do with this is, obviously you could graph it, right? So for instance, I could say -3, -7. I can go to my graph over here, and I could go 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, and put this dot right here, and that's my vertex. And then, graph your parabola. Now, in this particular case, if you do it this way, you don't know what the roots are, so you don't know where it crosses the y-axis, do you? But we're going to learn how to do that in our next video, and that's kind of a preview of where we're headed, is to how to find the roots when you can't factor. Okay, now let's talk a little bit more about why this is useful. Okay, let's go back to our picture here. Let me go back to this thing, get rid of all this. Let's say you had a parabola like this, and I asked you, what is the highest value this parabola attains? What is the largest value this quadratic takes? Let me actually write that down. What is the largest value this quadratic takes? I just realized that everything I wrote was just about illegible. I hope you understood what I was writing through the context of what I was saying. So, what is the largest value the quadratic takes? Question mark. In other words, when I ask for a value, I'm asking for a y value. What is the highest value this attains? Well, if you just look at the graph, the highest point is, in this case, the vertex. And what is that highest value? It's going to be this value here. It's going to be whatever that y value is. So in this case, this vertex is what? This vertex is -2, 5. So if I asked you, what is the largest value the quadratic takes? It is simply the y value of the vertex, because that tells you how high the quadratic went, right? Now, how do I know ahead of time whether the quadratic is going to have a high value or low value? In other words, how do I know that this quadratic looks upside down? Well, remember, if you have a negative out front, I'm kind of getting ahead of myself, but that's okay. If you have something like this and you have a negative out front, that's what tells you that it's upside down. And so if it's upside down, you're going to have a high value like that. All right? So let's put this a little more formally. If I wanted to know, let me go over here. What is the largest value of a function? So what is the largest? Oh, I do need to slow down and try to write a little better. I apologize. Largest value of the function y equals x squared plus 4x minus 3 takes, or attains, or whatever. So if I ask you that, I need a negative there if I'm going to do it this way. So what is the largest value this function attains or takes? Really what I'm asking you is, what is the y part or the y coordinate of the vertex? Because if you think about this, it's upside down because there's a negative, right? This means upside down. And this part up here, the y coordinate right here, is going to be the highest value that goes. So whenever you are asked what is the largest value, or in the case of something that looks like this, what is the smallest value, right? Because that would be then the lowest. If you're asked a question like this, what they're really asking you for is to find the vertex and then find that second number for it. Okay, not the entire vertex, but it's this number here. All right, so let's actually do that. So for this one, it's the same as it was before. Negative b over 2a is going to give us the x. It's going to be -4 over 2 times -1, because in this case, a is -1. That gives me -4 over -2, which is +2. Now I'm going to plug this back in. So I have negative, parentheses, 2 squared. This is very important, actually. Let me take a second. This is not -2 squared, is it? That's not how you... So you be careful not to write that. You can, and this is technically correct this way, but it's a little confusing. The only thing being squared is 2, not the negative. Okay, so 2 times 4 minus 3. So when you do this, you're saying it's not negative 2 times negative 2. This is 2 times 2, 2 squared, which is 4. But that negative is still there. It's just hanging out front. So it's negative 4, and then plus 8 minus 3. So negative 4 plus 8 is 4, minus 3, which is 1. So what is the vertex? Well, I didn't ask for the vertex, did I? It's important to know that I didn't ask for the vertex. But you have to understand that to find what I'm asking you for, you have to find the vertex anyway, right? Because what I'm looking for is the value that this function attains, which is the highest. And that is going to be this value. It's this one right here. It's not the whole vertex, it's just that one. Now, we have a name for this value. The largest value a function attains, we're going to call the maximum. So another way to ask this question would be, what is the maximum of the function, this thing? And you would say 1. You wouldn't give me the whole vertex because I'm only asking you for a number in this particular case. All right, let's try another one. What is the... Actually, let's do it this way. Sorry if you're taking notes and you started that. Does the function y equals x squared plus 5x plus 3, let's actually use a different one. Let's do 6x plus 3, have a maximum, or, now I'm going to pause for a second. It's either going to have a maximum, right? If the function looks like this is going to be a maximum, right? That's what we just talked about. But if the function looks like this, then really you're looking for the lowest value, right? So in this case, we're looking at a max. In this case down here, we're looking at a minimum. Either way, it's still the y value of the vertex, right? So either way, it's going to be the same number, but it's just going to be called something different depending on the context, right? So the question is, does this function here have a minimum or a maximum? Maximum or a minimum, that's our new term, minimum. And then find it. So without graphing this, you should be able to tell already. Notice in front of this quadratic, there's no negative, is there? This is a positive quadratic. And so you should immediately think, well, this looks like this, doesn't it? And if it looks like this, then it doesn't have a maximum value. You might think, well, the maximum is going to be infinity. Well, it doesn't technically have a maximum because infinity isn't a number. So we're not going to list infinity as the maximum. This has a minimum instead. So this is a lowest value. So does it have a minimum or a maximum? It has a minimum. All right, so this has a minimum. Oh, let me change colors here. It has a minimum. And we're going to find it. And how do we find it? We use the vertex formula and just take that second number. So let's do that really quick. So we have negative b over 2a. You don't have to write this little formula every time. If you want to jump straight to negative 6, you can, because b is 6. 2 times 1, just 2. So that's negative 6 divided by 2 is negative 3. And we're going to plug back in. So we have negative 3 squared plus 6 up. Slow down. Plus 6 times negative 3 plus 3. That gives me 9 minus 18 plus 3. That's negative 9 plus 3, which is negative 6. So does this thing have a maximum or a minimum? It has the minimum because it looks like this, right? And what is said minimum? Negative 6. That's how that works. Okay, let's do a couple more, then we'll call it a day. You try this one. Tell me whether this function, I'm not going to write all the words out, this function here, actually let's do a couple of them. 8x plus 4. Tell me if this has a maximum or a minimum, and then find it. Okay, here we go. I hope you've tried it. Hopefully you've gotten the correct answer. So first of all, we're going to assess whether this has a max or a min. This function, since it has a negative out front, immediately you're going to know, well, this looks like this, which means this is a maximum. It has a maximum, and it has a maximum at the vertex. So what are we going to do? We're going to find the vertex. That's the logic that you use. So the vertex is going to be negative b over 2a. It's negative 8 over 2 times a, which is negative 1. I'm going through this quickly because I'm assuming that you've already done these calculations. Negative 8 over negative 2, which gives me positive 4. So what do I do with that positive 4? I plug it back in. So this is negative. 4 is the only thing squared here. Plus 8 times 4 plus 16. Oh, sorry, plus 4. This is negative 16 plus 32 plus 4, which is going to be 16 plus 4, which is 20. So if I asked you for the vertex, specifically, you would give me 4, 20, the coordinate 420. But since I didn't, since I asked you for the maximum or the minimum, you're only going to give me the number 20. So we know this is a maximum, and the maximum is 20. And that's how you do it. Now, one little extra piece of information is kind of interesting to me. You might ask, well, what does this number here signify? What does that represent? Well, you can think of it as kind of telling you when this maximum happens. So if you were to think x is time and say y is a height, or y is maybe a cost associated with some kind of business model, then this number is going to be when, usually. Or let's say your function tells you how many units of something you can sell before you start losing money, and what's the maximum amount of money. So you could think, okay, time might be after 4,000 units, you're going to make a maximum profit of $20 million, right? But after that point, it's going to start dropping. And so you can think of this, here's 4, here's 20, as when you're going to reach the maximum. And what is that maximum? 20. Right? Just kind of a neat way to think about this. We haven't really gotten into the applications of these things, but the applications of quadratics are almost endless. You can use them for, like I said, cost functions in business to find out when and how to maximize profits. You can use them for physics problems. If you were to throw a ball into the air and ask, how long does it take to get to the top of its flight, and how high is it? So this might be after 4 seconds, it reaches a height of 20 meters, something like that. So that's really what these things are used for. And maybe we'll do a video in the future kind of going through some application problems, if that would be interesting to you guys. Okay, I think I'm going to end it here. That's pretty much all there is to finding the vertex. And you can, like I said, you can use this whether you can factor it or not to find the vertex. And the vertex is going to give you a minimum or a maximum every time. All right. And in the next video, we're going to learn how to find roots of these things without having to factor them. All right. Thanks for sticking with me, guys, and I'll see you guys in the next one.